students want to know. All of a sudden I have this. Negative, and guys, make sure I have this stuff down correctly. I think I had the red one look like that. And my students, most of my students in class, maybe all, said, yes, professor, if I actually clean up that red one, it could turn into the blue one. So they're equivalent. But professor, suppose on the side here we go, guys. You gave me g of x, I mean the red, blue one. You gave me the f of x to be this. And I didn't see the red one. You gave the red one to me. But yet you asked me to sketch the graph of it. And the way the blue looks, all by itself, or just the blue, the red's not given. The way the blue looks, I cannot myself. The way it looks right now, if you ask me to sketch it, it would be difficult for me to sketch. Because I don't have it in the form where I can see the shifts. So the class, the chapter 2 for the class is show students how to change this into this. How can I go from the blue to the red? And guys, it's going to require something called completion of the square. So first though, we point out, your textbook calls the form we're after a form that looks like this. Now we use the same symbols that your textbook uses. They're saying please have maybe a coefficient out front, they call it a, then x minus h squared. In fact, I had an x minus h squared here in mine. And then on the end they call it k, my k was the 16. And they want you to look something like that. And they call this the vertex form. So what they want us to do in the remaining time I have tonight is to place the blue, and some others coming up, into what they call the vertex form. Make it look like the green, which actually turns into the red for us. How am I going to do that, guys? It's going to require completion of the square. So we'll go back to the blue, trying to keep all these colors same. I'm going to rewrite this with a y rather than f of x. Now watch carefully. There's the original blue. I want to complete the square on it. Now I know it's been quite a while since we've had a completion of the square. The leading coefficient should be a 1 for completion of the square. It's not, it's a negative. I can make it a 1, divide or multiply by a negative. I'm going to quickly change this in order to make my leading coefficient a 1. Therefore, my leading coefficient is a 1. The way we approach completion of the square in this class is we move the 12 over, out of the way, and came up with the number that will now complete the square. In fact, I think I've used blanks. Now, can anyone recall, on the right-hand side is where this is taking place, what number must be added on that blank to make this work out for completion of the square?
The half of b
Half of, in this case, half of a negative 4,
squared.
then squared. So that result will be
4.
4. And you got to put it on both sides. This is the way we, in this class, did it. Therefore, that makes the right-hand side, which we want, look at this, it's a nice perfect square. That's what we wanted. The other side would be at this point negative y plus 16, 12 plus 4. Completion of the square. Now to find y, move the 16 over, because eventually at the end you want y all by itself. Divide or multiply by a negative, and you're going to end up with, if I have no mistake, after completion of the square, you took the blue, complete the square on it with completion of the square process, and made it look like this, which is the red. So if the red's not given to you, you've got to use completion of the square to put in that form, and then graph it. Okay, and that's what my students who were coming up to me at the break were concerned about. Professor, how do you go from this to that? How'd you know that? I gave it to you. But now I'm not gonna give it to you. You have to start from scratch and complete the square on your own, and then graph it. Now guys, with all that said, part two, I'm gonna do this. I'm gonna give you a function. I think it's on the handout that you're gonna eventually get. I don't think you have a handout yet. We'll get to you. It looks like this. The function is f of x. Now guys, watch very carefully. I'm getting excited about this. 2x squared plus 3x subtract 2. Here, sketch. I'm going to sketch that. Now, bear with me, it's going to take a little time. Can anyone tell me, at this point right now, will it graph into a parabola? Should it graph into a parabola? All quadratics graph into a parabola. It's going to graph into a parabola. Can anyone tell me how far down or how far up it's been shifted? No. Can you tell me horizontally how far over to the left or to the right it's been shifted?
No.
No. You might be able to tell me because of this, you might be able to tell me whether there's a reflection or is it upside down. You think it's going to be upside down on this one? I don't see a negative sign stuck out front. Okay? I cannot graph it, even though it's supposed to be a parabola, I cannot graph it until I put it in, look at this guys, the ring. And then I'll graph it. I realized way back, I was helping my nephew with his math one day. And it's so tempting to say -2. Professor, -2. -2 is a vertical shift. You're supposed to shift down 2. No, you're not. You don't have it in the correct form yet. I'd be tempted to also say, doesn't -2 say vertically shift down 2? No. It's not in the correct form. It's not in vertex form, they call it. Guys, let's put this in vertex form by completion of the square. I would suggest you write this as y. It's easier than the f of x. Now the trouble with this one, if I want to complete the square, is that leading coefficient should be a 1. Mine's a 2. I gotta get rid of it. Divide both sides by 2. No problem. And there's, my division's correct here, that's division by 2. Okay, that's, we'll call it step 1, go for it. Step 2, let's move that 1 over and get ready for completion.
9/16.
Oh, I'm here already. We've done these completions so many times. Now I'm hearing, I heard,
Yeah.
Lisa says, Professor, you take half of that coefficient in the middle, and half of 3/2 is what, 3/4? Then square it, and she says that's 9/16. Guys, watch carefully because I'm going to do a lot of work with this problem. Lisa, if you are correct, can you tell the class what is this as a perfect square?
X minus,
Not minus.
no, it's plus 3/4.
It is. That's what she wanted. She wanted a square, complete the square. She got it. The other side, I need to do some arithmetic here. So you guys can write this as y/2, and I need to combine my 2 terms there with a common denominator of 16. 1 plus 9/16. I'll do it quickly. You'll get 25/16. You put those 2 terms together. Now I need to solve for y. I'll put it right here. I get y by itself, we'll be finished. Let's write y/2. Let's move that 25/16 over to the other side. And if I want y completely by itself, I think every student in the class would say, well, Professor, multiply everything by 2. And the 2's would cancel on the left, that's what I want. On the right, you get a 2 out here, on the right-hand side. And can anyone tell me, by the time you reach, I'll put it right here, by the time you reach that last term, you're multiplying by 2, what would that give you? What's the last term? I'm multiplying everything by 2. What's 2 times 25 over 16 is equivalent to?
50,
Well, you call it 50, I'll just do a little canceling, call it what, 25 over 8? Is it, guys? Do this. Is it? 25 over 8? Whew. Now, this is why I'm getting excited about this. No one, I don't think, no one, even a professor, if you met a professor and say, I think about this. Oh, you are? Guess what that is equivalent to? This. Look how different they look. This in the blue is the same as the one in the purple down there. They are the same. They're equivalent. Why on earth would I mess up a nice, well-behaved function up here with those nice whole numbers, 2, 3, -2, and put it into the other form, which is equivalent to it, but the other form has fractions? Why would I do that? Why on earth would I take the time to change that well-presented function at the top of the board into that purple, which has fractions involved? Why can't I just leave it in the original at the top? Why did I do that with that completion of the square? Why?
So you can see the changes to the graph.
So now I can see those transformations and graph it. By the way, guys, who on earth would think, I wouldn't, who on earth would think that this says you're supposed to horizontally shift it to the left 3/4 of a space? You couldn't tell that from this up here. No way. And who on earth would think that you're supposed to vertically shift down 25 over 8, which is 3 1/8? You would never guess you're supposed to vertically shift down 3 1/8. Look at the blue. But that's what the graph does. And you cannot find that until you put it into this awkward vertex form. Now, on the side here, a little vocabulary as I go along. The turning point, even before I get to the grid, we'll call it vertex. The turning point. Anyone tell me, where is my turning point, the coordinates? Based on just what you see here, you've got a shift to the left and a vertical shift down. Anyone tell me, based on a shift to the left, horizontal shift to the left, and vertical shift down, can anyone name the coordinates, precise coordinates for the vertex, the turning point?
maybe -3 over 4.
Love it. And?
-25 over 8.
Lisa. Nice.
I have a question.
That's my turning point. That's a shift to the left and a vertical shift down. Yes?
I have a question. As we, there's the 2, so do we also need to multiply?
No.
No?
No. No. You want to multiply something by that too. You see that 2 sticking out front? I know what worries you. No, you don't want to mess with that 2.
Oh, it's just the vertex.
Yeah.
Okay, just determine.
Now, guys, I'm not going through all the transformations involved here, but I'm going to go directly to the graph here shortly and see what that graph looks like. Anyone tell me what this right here would actually tell me to do if I were to be doing with different colors, the parent graph and then each transformation? What would this transformation here indicate to do? Horizontal shift, horizontal stretch, vertical shift, vertical stretch, reflect through the x-axis, reflect through the y-axis. What does that 2 out front tell you to do to begin with? Oops.
Horizontal stretch by 1/2.
Not horizontal. No, that would be inside. That would be inside the parentheses.
It'll be a vertical shrink.
Oh, close. Close.
Vertical stretch.
Vertical stretch by a factor of 2.
2.
If it's inside, it's a horizontal. That's where you gotta be careful. Yeah, this is a vertical stretch by a factor of 2. The graphs have been stretched. I'm not gonna show all those transformations. This says, Lisa, you help us out? This says horizontally now shift the graph for my next color, if I were doing it. Shift the graph 3/4 of a space to the left, horizontally. And then take another color and shift that down what? 3 1/8 vertically. And that's your last graph. We don't have time to do all those transformations. We know how to do it. No, I just want to go to the final graph. I just want to go directly to the final graph and get that done. Guys, let's do it. Let's see what the final graph may look like. Here we go. Okay. Now, let's see what we can do here. Out -3/4, down 3 1/8. Guys, we'll mark -1 right here and show down 3 1/8. We'll go down to a -4, bear with me. And -1, -3/4, down 3 1/8. I would say it falls right in here somewhere. Guys, we'll name this as my vertex. -3/4 down 25/8. Squeeze that in. That's what that point there represents. Just estimate it out. -3/4 down 25/8. Are we okay with that? That's my turning point. Now, should this graph open up or down? Up. I know it's being stretched, but it should open up. If it opens up, this is my turning point, it's going to do this. Is it going to intersect the x-axis?
Yes.
So I'm going to have x-intercepts. I need those. And the fastest way to find the x-intercepts, take my function, set that equal to 0. I hope it factors. For goodness sakes, we've got a long night here. Let's try to factor. 2x, x, plus 2, minus 1, Mr. Park. Do not let me make a mistake. I think it factors. Split this up. We're going to end up with 1/2, -2. Guys, I prefer ordered pairs, which I think you should. Those are my x-intercepts. Let me plot those right now. Use a different color. Those, let's put those in red. And it looks like, guys, it's a negative, 1/2, positive 1/2, 0. Place 1 here. Just give a rough sketch. And 1/2 right here. That's my x-intercept, and there's another one over here at -2. Here. Those are my x-intercepts. What else would be helpful before I sketch? Intercept. Is that true?
Yep.
And to find the y-intercept, go back and replace x by 0 or find f of 0. Easily done here. Replace all these x's by 0, you get -2. Best expressed as this. 0, -2, and here we go. I'm gonna place it right here. -2, there's my y-intercept. Do I have enough now to connect those points and form the parabola?
Yes.
Well, of course I do. If I connect those, let's connect in blue here. Guys, just gotta sweep down, pick up that turning point, come back up, pick up that, go forever. There's your graph. There's your graph. Done. Is it true? Now, suppose on the quiz next Wednesday, I have one of those on the quiz next Wednesday. Suppose you make a mistake. You say, wait, Professor, I saw all that business you're doing here. If you make a mistake in this, you're going to miss the graph. You're have a horizontal shift somewhere else where it should have been here. You made a mistake in your completion of the square, and therefore you get your quiz back and got 0. Out of 10. You don't want that to happen. So you gotta be very, very careful. What I would do, I always give plenty of time on quizzes and exams. What I would do is, if you have the time, and you will have time, I would take, here it is, this, give me some scratch paper, multiply this out, expand it out, and it better take you back to this. It looks like it may not. Look how strange that looks. If you clean this up, simplify this in the purple, it better take you back to the blue. I would check it like that before I start graphing to make sure at least that part's correct. Okay, so the graph's done. Is that true, guys? Is the graph done? Now, if I ask you, locate for me, and I know your textbooks just calls it a maximum or a minimum. They don't call it local and absolute. I prefer local, absolute. Is there an absolute minimum value, I'll just abbreviate here, on this graph?
Yeah.
It drops down to the lowest. What number would you recognize as the absolute minimum value? A negative 25, was it, over 8? That's the lowest you can get this function. Look at this function here. That's the lowest this function will drop down to. I don't care what you replace x by. Hey, if you replace x by 1,000, and you crunch it out, 1,000 squared, 3 times 1,000. I put a negative 1,000, let's say. Let's put a negative 1,000 in there. Put a negative 1,000 in there, you do that business, you do that business, you say, Professor, I crunched it out with a negative 1,000, I got an answer. That answer better not be lower than negative 25 over 8. That's the lowest. A negative 3 1/8 is the lowest value you can get. Yes?
This is kind of semantics, but if you're being asked for both the absolute and local minimum or maximum of something, and it's something like a parabola, what would you write down for both answers?
Beautiful. Here we go. If they should say, or I should say, is there a local minimum on this graph based on what we know about local in a particular locality? Is that point still lower than all points nearby it?
Yeah.
Yes. So the local is the same as the absolute. I think that's what you're concerned about. Is that true?
Yeah.
Yeah, they match up. They're the same. Your textbook just says maximum or minimum. They leave off the absolute. They just go ahead and say, in this case, is there a minimum value? And it is still negative 25 over 8. Yes?
Why we write only for the y value?
Wait, hang on now.
Why we write only?
Beautiful. Can anyone tell me if they, or ask me what function or what value is my minimum on this function, minimum value? Why am I, good question, Lisa, why am I considering only the y value and not the negative 3/4?
This is a parabola, so the domain would usually be negative to positive.
Okay, and what would the range be?
The range would be negative, well, in this case, it'd be negative infinity, or no, sorry. Negative 25 over 8 or positive.
Beautiful. The y values are the up and down. That's what you want. How far down does it drop? The x is the horizontal, it's stretching this way. No, when they ask you for a minimum or a maximum, that's dropping down or going up. It's always the y, or the max or min. That help?
Yeah.
Always the y value. Okay. Okay, guys, got that done. Geez. What else should I do here? I don't want to leave it right now. Well, of course not. Can anyone tell me where is, since you have something like this on the quiz Wednesday, where is that graph increasing? And you're looking at it from left to right. Where is it rising as you go from left to right? And I'll illustrate, see if you guys would agree. If I'm going from left to right, is this piece falling?
Yes.
So this piece is falling. But by the time I hit that vertex, turning point, does it now turn and start rising as I move from left to right? So the part that's increasing is that part there. How would you describe, when is that happening? Now, Lisa, we're on the x-axis, isn't it now? Where along the x-axis is it increasing? Negative 3/4. Beautiful. That's where it's increasing. Along the x-axis, the -3/4 infinity is rising, increasing. Of course, you see where the decreasing is, but that's increasing, decreasing. We got a absolute min, we got a local min, beautiful. Oh, what else could I ask? Seems like there's more I should be asking here. Well, of course. This. When is that true? When is that true? If your graph is correct, when is that statement true? Without sign analysis and all that business. Go for it.
Looking at -2 to the 0.
That number right there, what was it? 1/2?
1/2.
I think it was 1/2. You're done. Is that true, guys? Increasing, decreasing, max, min, all that business could be answered easily now, right? But you gotta get the graph. You get the graph wrong, you see where you're gonna miss all this other stuff. Domain. The domain from left to right, the x's, definitely is open. The range, though, is not open. The range, the up and down, it drops down to what? We said -25/8, was it?
Yeah.
And it rises through infinity. Is that true? No problem. How you gonna miss something like this? Jeez. Okay. Now, this is where we close down. At least this part. On the side here, this is all nice. Nice. Part 3. I'll give you a handout here shortly. Here goes. Given. And we'll practice a little bit for that quiz on Wednesday. Given this, f of x is equal to this. Guys, enjoy chapter 2 as long as you can. It's nothing but parabolas. Quadratic, quadratic, quadratic. If I copy that down correctly, 3x squared subtract 2x minus 1, that's your quadratic function. Now, I'd like to know, what is the, and by the way, I'm not going to graph this one. Would the graph open up or down? Without me graphing all the details, just based on what you see right now, would you expect the graph of this quadratic to open up or down? Why?
Because there's no minus.
There's no minus sign out front on that leading coefficient, so there's no reflection, it's not flipped over. It's just gonna open up. If it opens up, am I guaranteed, or parabola, am I guaranteed there is a minimum in there? If it opens up.
There's also guaranteed
It-
X.
Tell me more.
There's also guaranteed an X and it's
Oh, beautiful.
oh well.
She's telling me, Samantha's saying, Professor, if you actually graph it, which I'm not gonna graph it. If you're actually graphing, then there might be some x-intercept, there might be a y-intercept. All I want on this one to sort of close down, and I'm not closing all the way down yet, but I'd like to know, where is this, I'm just call minimum, what's my minimum value on this function staring at me? What is the lowest value that this function can take on, no matter what x you put in there? There's a low point it goes down to. I like to find the minimum value for this function. Aiden, I don't want to graph it. But I'm asking for the minimum value. I'm asking for the minimum value. Oh, you're gonna like this. You're gonna like this. And I do not want to graph it to find it. Graphing, I love graphing. Intercepts, all this business, opening up, opening down, minimum value. I love graphing. You guys do well on graphing. But now we're to a point where maybe you don't have enough time to graph it, and all of a sudden the question comes up, still give me the minimum value. But you don't have the graph staring at you. Who has an idea? And wait till you see what I'm gonna do. So you need not, after I show you in a few minutes, this technique, you will be able to find the maximum or minimum value of a quadratic and not even see its graph. Don't even have to worry about completion of the square. Don't do it. Now, let me get some input, and I'm gonna close down with this and get a handout to you guys. I saw some hands going up. Yes?
You put it in vertex form.
I can, thank you. First, I can put it in vertex form. She says, Professor, go back and put it in, I think I had it over here somewhere. Here it is. Put it in this form. It says complete the square, rewrite it, put it in that form. No problem. Now, completion of the square is a little iffy, because if you make a little mistake, then whoops, it may be off a little bit, but we're gonna try it. Here goes, guys. Complete the square is the way we're gonna do it. What a class this has been. Okay, guys, we'll rewrite this as y is equal to 3x squared, subtract 2x, subtract 1. Just rewrite and put a y in there. What's wrong with my completion of the square to get started?
Coefficient is.
The coefficient should be a 1, this is 3, so divide everything by 3. Make this real quickly, even though I am going to end up with some fractions, that's okay. This is division by 3. Now, completion of the square says move that 1/3 over, out of the way, and get ready for this. Now, we've done completion of the square so much in here, don't put the wrong number on there. What's the number required here?
1/9.
1/9, thank you, Lisa, 1/9. Put the wrong number, you lost all your points. Therefore, she has now, for a perfect square, the right-hand side is this, x subtract 1/3 squared, which I wanted. The other side, arithmetic, put those two fractions together. So we'll write this as y over 3 plus, put together with the common denominator of 9. Guys, I think it's 4/9. Someone check me out. Is that 4/9? Yeah, put together fractions.
Yeah.
Yeah. Then I run out of space here, bring it up here, move that 4/9 over. And you're going to end up with this. And then do what to finish up?
Multiply by 3.
Oh, thank you. Multiply everything by 3. Nice. We're going to have y is equal to 3. X minus 1/3 squared, do not expand that out. Can anyone tell me, by the time you reach the last term, you multiply by 3, what are you going to end up with? By the time you reach that last term.
31/9.
Minus what?
Negative 31/9.
No. What are you going to end up with? You got 4 9s, you times 3. Can you do a little canceling? Can you call it 4/3?
4/3.
Yes, no? Okay. Gee, oh, by the way, so now in vertex form. It's now in this form. Looks like this. Now I'm not gonna graph it. Can anyone now tell me where is the vertex? If this is done correctly. Aiden, where's the vertex located?
-1/3.
Hold on. Be careful. Remember that says it's gonna be horizontally shifted to the right.
Right, sorry, +1/3.
Positive 1/3.
Down -4.
That's it. Now we all do that. And then -4/3 stays like it is. That's my y. There's no vertex.
So
I hope we didn't make a mistake. Now, the question was though, find the what?
minimum.
The minimum value, and we said this thing opens up, so there's a minimum value. Final answer is, no graphing, you're done, what's my final answer? -4/3. That's your minimum value. I'll put it right here. Oh, beautiful, beautiful, beautiful. Completing the square. Now here's where we end. Now I realize we're at the end of class, we may be getting a little tired. Watch carefully the way we end class. Where I get those handouts to you. Here we go. Let me ask you first, before I do this, to close down class. Wouldn't it be nice if, for example, on this one, when I ask you to give me the minimum value, which came out to be finally -4/3, wouldn't it be nice to be able to find that -4/3 within seconds? Would it be nice to find that -4/3 without completion of the square? Completion of the square works, but it takes a little time. Would it be nice just to say, Professor, is there a quicker way to find that without going through completion of the square? That's what I want you to close down with. Here we go. Now, I've got a class of mathematicians. So, we'll go down, we're gonna do this. And I don't want anyone to get scared. On the side here, we'll start out with a standard quadratic. I'm gonna name it this. Let's just take a standard. And let's complete the square on it. Now, Lisa, you've been answering those beautiful questions. Now, can you tell the class with the standard, and I still want to complete the square on this to get to something. What's wrong with it right now if I want to complete the square?
The leading coefficient.
Leading coefficient should be a 1. I have an A. What should I do?
Divided by 8.
What should I do? Not multiply. What did I do over there? I think I divided everything by 3. Was it 3 over there?
No, yes, I said, yeah, divide
By A.
Yeah.
So divide everything by A.
Yeah.
And by the way, guys, I prefer Y here. I think it's easier. Oh, watch carefully. Oh, watch carefully. Divide by A. See, we ended up with this. Everything by A. A. Step 1. Just like I did that one over there. Except we had a 3 over there. Next, I think we moved, if I'm correct here. Where am I? Yeah, we moved, I think, in the next step, after we divided, we moved the 1/3 over, I think, to the other side, got the x's isolated. So guys, on this one, we'll move not a number, but C over A needs to be moved over. And get ready for completion of the square. Same thing we did over there, except we have letters, variables. Now don't lose it. This is the end of the class, don't lose it now. By the way, is that the same process I did over there? Except we have variables, letters. Same process? Now, can anyone tell me what is required on that blank in this general form? Back here, Aiden, 1/9. What's required? What's required on this one?
B squared over 4A squared.
Whoa! Lisa, she says, Professor, it looks awkward, but what we do, we take 1/2 of that coefficient. I know it looks awkward, which is B over 2A. And then do what with it before I place it on that blank? We square it. She says, I think, Lisa, you said this. Was
Yes.
it B squared over 4A squared?
Mm-hmm.
That goes here. Both sides. Just like I did over there, except I had numbers to work with over there. Now, if she's correct, guys, right here, I did this business, show you where that came from. We had variables rather than numbers, doing the same thing, folks. Now, I'll erase this, guys, that's where it came from. Now, if she is correct, and I'm gonna tell you she is, that right-hand side should be, the whole purpose here is, that should be a nice perfect square. It's gonna look awkward. Okay, whichever what you think it is.
X plus B over 2A.
Wow, is she on it today? Whoa. It's definitely what it is. Now, the other side, you're supposed to put these two together. We're gonna clean this up, like I was doing, let me try to find it. Oh, look there, I blocked it up also here. Like I was doing here in the arithmetic, you're putting these two together with a common denominator. Same thing over there, except I have variables. Now, to put those two together at this point, I need a common denominator of, what do you think I'll accept for my common denominator?
4A squared.
4A squared. I need to put those two together. I'll put a plus sign here. All that should be over 4A squared. If it is, my first fraction needs to be multiplied by 4A. Bear with me. Now, those two now are over the same common denominator, 4A squared. What's on top? B squared, I like the positive first. B squared is on top, minus 4AC. That's this on top. I'll put the B squared first, looks better. Guys with me?
Mm-hmm.
Woo! That's step 2. We're almost finished. Step 3, I think now we are ready to, and I may have written it out somewhere on through here. I'm supposed to now get the y, where is it? Oh, get the y by itself. That's the last step, get the y by itself. Help me out here, guys, get the y by itself, it's gonna be awkward. I got y over a. I need to move this term over. Can anyone tell me, if you move this term right here over, what might it look like? Because it's gotta be moved. Because I gotta finally get the y by itself. Can anyone tell me what effect you think it will have in picking this up and bringing it over here? This term here. Yes.
Does it become minus B squared plus 4AC?
Oh, hold on. Minus b squared plus 4ac, love it. That's exactly what it's gonna be. They change signs. Minus b squared plus 4ac. So when I bring it over, I'm gonna write it like this. Put the 4ac first. Just to make it look better here. 4ac minus b squared. Still over that common denominator of 4a squared. That's it, moved over. Wow. Now, hang on, I'm getting too excited. Let me catch up with where I am. At this point, guys, we have this. I don't want to lose it now near the end of class. This, and then with his help, we have on the end plus this. What a good way to stop class tonight. That. Awkward as you know what. Now what do I need? I need one more step. I want the y completely by itself. What's my last step?
Multiply by A.
Thank you. Multiply everything by A. A's cancel on the left. gives me a y, which is a 1. Multiply this by a, put an a out front. Beautiful. Multiply by a down here. In fact, I'll put it right here like I usually do down there. Guys, can anyone tell me the full effect on the last term, which is awkward, if I multiply by an a or do a little canceling?
That would be 4c minus b squared over 4a.
Oh my goodness. Oh my goodness. Oh.
No, Professor, that would be just like the numerator just 4c because we cancel 4c.
Are you telling me it's correct or not?
No, you're right.
Are we okay?
The A you bring in from A over 1 gets canceled instead of what?
No, I'm just checking the numerator should be.
No, you don't mess with the numerator. You multiply by a here, all I do is cancel this a.
Just cancel.
I canceled.
Just checking, thank you.
No, I see what you're saying.
Yeah.
Oh, I don't want to be thrown off now. I see what you're saying. Wow. What a, oh, Mr. Park. If the class does not appreciate what's going to happen now after all this, now, can someone in this clever class tell me? I hope all that completion square is done. Can anyone tell me, even on this awkward form? A gave you the vertex on this one to be this.
Negative.
He said easily, Professor, 1/3, negative 4/3. It's negative 4/3. It was. Now, this is in the form I want. Can someone venture out and tell me what are the coordinates of the vertex? Even though it looks strange as you know what. Samantha, go for it.
Well, in this case, it'd be negative b over 2.
Hang on now. Correct.
Comma, 4ac minus b squared over 4a.
Now you have a formula to find the vertex, and you need not go through completion of the square to find it unless requested. You now have a formula. Now to close down, now it's just very in close to close down time. Now, if we accept all that with all those variables floating around, I'm gonna go back to what I just did, and here we go. I was trying to find the minimum value. Now, since I have a formula, let's not go through this again. Let's see if we get this. If I accept that formula, the first coordinate, in this case we 1/3, x, should be equal to, let's find it, that. That's my first coordinate. Just place negative b over 2a in your function. Okay, in this case, it's negative. And guys, in the original function, b was what? Negative 2, right here. A was a 3, so you got negative 2 over 3. All that turns into 2/3. Oh. How did we mess up? What did I mess up? Did I mess up myself? Negative b over 2a? Come on, Randy.
Multiply 2 by A.
Okay, negative b over 2a. Hang on. What did I do here? This is b, this is a. And we got negative b over 2a. Is that true, guys? Now why am I getting 2/3 when we finally got over here 1/3?
Because it's 2 times 6.
Tell me again.
2 times 3 is 2 6.
2a, so it's 3 times 2.
It would be 2, negative 2,
So
6.
it's-
Yeah, multiply 2 and
It's 2 over 6.
2 over 6 here.
Yeah.
A. Yeah.
What's wrong with me? Negative b over 2a. My a is 3. We
Yeah.
don't talking here. 2 times 3, come on, man. Is that 1/3?
Yes.
Is that what we got earlier? Who on earth would not prefer to use negative b over 2a than going through all this? Would you prefer that? Now, I'm scared. If you want to find the other coordinate, in this case it came out to be, if we have no mistake, negative 4/3, I'm supposed to use this formula. This had better be negative 4/3. I'm gonna cry. This place is so nice. I'm gonna cry if that does not work out. That had better give me a negative 4/3. Here it goes. We'll try it right here. 4. Guys, a back here was 2. 3. C was it negative 1?
Negative 1.
Then subtract b squared, and b was a,
-2.
was it a negative 2?
Yeah.
Negative 2. That's being squared. All over 4 times a, and I think a 3 here.
Yes.
It was. Let me make sure I put everything in correctly. Now this is why I'm getting scared. That had better give me that. Here it goes. This is a negative 12. If I square negative 2 on the end, I know that's 4. That says what? Minus 4? All over 12. A negative 16 over 12, reduced down by 4. What is that, guys? 4/3?
Mm-hmm.
What do we get over here? Oh. Negative 4/3. Would you guys prefer to find these by using the formula? If not, request to do it by completion of the square, would you prefer just go directly to the formula, put negative b with 2a in, put your numbers in, calculate, who wouldn't?